The resonant frequency is independent of R, but the sharpness of peak depends on R. The peak is higher for smaller values of R. Thus the resonance is sharp for small r and a flat one for large capital R. Capital R means resistance. The sharpness of resonance is measured by a coefficient called the quality or Q factor of the circuit. So this quality factor or Q factor is very much important. It is being asked for the last so many years. It is being asked in resonant in this series RLC circuit. So you have to learn this graph of this quality factor. So in this, what we have observed that this quality factor, it depends on the resistance R of the circuit. So sharpness of resonance and we call it Q factor. Q factor means quality factor. We call it quality factor. The resonant frequency is independent of R. Okay. So what is this Q factor? This Q factor is this. First of all, we will study this graph between the peak value of current and radial velocity omega. So graph is like this. Omega and I naught. So omega is equal to omega R. Omega R means resonant frequency. And what is this resonant frequency? We have studied it earlier that what is this omega? What is this omega R? Omega R is we have I naught is equal to E naught upon under root R square plus XL minus XE. I naught is equal to, I naught means maximum value of current, is equal to maximum value of EMF upon under root R square plus XL minus XE ka whole square. So we know that what is this XL? XL is omega L and XL is omega L and XE is 1 upon omega C. So for obtaining this we have done, I am just giving it a recap of this which we have done in the last class. For obtaining maximum current, what is this? This is Z. Z is impedance. Z must be minimum. For obtaining maximum current, Z must be minimum. That is, and resistance cannot be zero. Resistance will have a little bit value, some value. Resistance will have some value. The resistance cannot be zero. So this XL minus XC is whole square. This is a perfect square. And what is the minimum value of a perfect square? The minimum value of a perfect square cannot be negative. It is always zero. The minimum value of a perfect square is always zero. So XL minus XC's whole square will be equal to 0. So XL minus XC's whole square will be equal to 0. R cannot be 0. So we can equate this XL minus XC is equal to 0. XL minus XC's whole square is equal to 0. It implies that XL minus XC is equal to 0 and XL is omega L and XC is 1 upon omega C is equal to 0. Now, omega L is equal to 1 upon omega C. If we bring this omega here, omega R, and this L here, omega square is equal to 1 upon LC. It implies that omega is equal to 1 upon under root LC. 1 upon under root LC. And what is this? This is omega R. This is resonant frequency. So when omega is equal to omega R, then at that value, at this resonant frequency value, if the graph between omega and I naught is a flat one, it means current is very low. It means current is very low. Current very low, current can be very low. Actually, this is 0. XL minus XC is 0. When we are talking about resonance condition, then XL minus XC is 0. So if this current is very low, then it is very much clear that R is very high. So here it shows that current is very low. It means that high R. R means resistance, high resistance. This is moderate R. Moderate R, neither very high nor very low. Moderate resistance. And this is low resistance, low R. Is this clear to you, Anusha?
Yes, sir.
Okay. Then after that, the Q factor. The next point is this. The Q factor of a series resonant circuit is defined as the ratio of the resonant frequency to the difference in the two frequencies taken on both sides of the resonant frequency, such that at each frequency the current amplitude becomes 1 upon root 2 times the value at resonant frequency. The value at resonant frequency. So I am drawing a different graph. I am taking this one. I am taking this the low resistance graph, and I am drawing it again here. So on x-axis here, on x-axis we have omega, and on y-axis, we have omega, and on y-axis we have this current I. We have current I. Now I am taking this low resistance graph. This is a bell-shaped curve. I am drawing it here like this, and now the peak value. The peak of the current, it means that maximum current I naught will be obtained when this radial velocity omega is equal to omega r. So what is this value? This value is I naught. I naught is equal to E naught upon R. And what is this value? This value is I naught this value is I naught upon root 2. This value is I naught upon root 2. And what is this difference called? This we take this value as omega 1 and this value as omega 2. And what is this difference called? This difference is called bandwidth. This is called bandwidth. And bandwidth is equal to 2 delta omega. It is equal to 2 delta omega. Now, mathematically, Q is equal to omega r upon omega 2 minus omega 1, and omega r upon, what is this omega 2 minus omega 1? What is this omega 2? Omega 2 is the length from origin to this point, and omega 1 is the length of origin from origin to this point. So if I subtract omega 1 from omega 2, then I will get this length, and this length is equal to bandwidth. And why I am calling it 2 delta omega, I will tell you this. So we can write it 2 delta omega. 2 delta omega. 2 delta omega means this distance is delta omega, and this distance is also delta omega. That's why this complete distance is also called 2 delta omega. Okay, so we can write quality factor like this: Q is equal to, what is this omega r? Omega r means resonant frequency. Omega r means resonant frequency upon 2 delta omega is bandwidth. This is bandwidth, where omega 1 and omega 2 are the frequencies at which the current falls to 1 upon root 2 times its resonant value as shown. So what is this omega 1? Omega 1 is that value of frequency where current falls to 1 upon root 2 times, means I naught upon root 2 times its maximum value. Omega 2, at omega 2 also I am getting current equal to I naught upon root 2. Now, on to page number 24 of your notes. Shall I move on to the next slide? Have you noted it down? Anusha?
Yes, sir.
Okay, so on to the next slide. Omega 1 is equal to omega r minus delta omega. Omega 1 is equal to omega r minus delta omega. And similarly, omega 2 is equal to omega r plus delta omega. Okay, let's clear it from the graph also. What is omega 1? I have written omega 1 is equal to omega r. What is this omega r? Omega r is this length. And if I subtract delta omega from omega r, I will get this one, omega 1. That's why omega 1 is equal to omega r minus this one, delta omega. And in the same way, what is omega 2? If this length from 0 to this, origin to this is omega r and this is delta omega. That's why I have written omega 2 is equal to omega r plus delta omega. Is that clear to you? Omega 1 is equal to omega r minus delta omega, and omega 2 is equal to omega r plus delta omega. Is this clear?
Yes.
Okay. The frequency range omega 2 minus omega 1, 2 delta omega, is called bandwidth. Now, expression for quality factor, Q factor. Expression for Q factor. Clearly, at omega r, the impedance is equal to capital R, while at omega 1 and omega 2, its value is root 2 R. At omega 1 and omega 2, its value is root 2 R. Z is equal to At omega r, the impedance is equal to r, while at omega 1 and omega 2, its value is root 2r. So, at omega r, z is equal to r, but at omega 1 and omega 2, at omega 1 and omega 2, I naught is equal to E naught upon root 2r. I naught is equal to E naught upon root 2r. I naught is equal to E naught upon root 2r. Why? Because at omega 1, I is equal to I naught by root 2. I is equal to I naught by root 2. And we know that I naught is equal to, we know that I naught upon I naught is equal to E naught upon r. Therefore, I naught upon root 2 will be equal to E naught upon root 2r. And what is written here in the denominator? In the denominator, I have impedance. Is that clear to you? I naught is equal to E naught upon r. This we know that. I naught is equal to E naught upon r. If we divide both the terms, if we divide both sides by root 2, so I naught upon root 2 is equal to E naught upon root 2r. And what is written in the denominator of E naught, in the denominator of EMF? What is written? It is impedance. In the case of series LCR circuit, the denominator of E naught means it is impedance. So at omega 1 and omega 2, I naught is equal to E naught upon root 2r. And actually not I naught, it is I, current, the value of current. The value of current is E naught upon root 2r. So Z is equal to root 2r. Therefore, Z is equal to under root r square plus omega L minus 1 upon omega c is whole square is equal to root 2 r. Now, squaring both sides, on squaring under root will get removed, so r square plus omega L minus 1 upon omega c whole square is equal to, what is the square of root 2? It is 2. And what is the square of r? It is r square. So we will keep omega L minus 1 upon omega c is whole square here on the left hand side is equal to 2r square minus r square. So omega L minus 1 upon omega c is whole square will be equal to r square. It implies that omega L minus 1 upon omega c is whole square is equal to r square. It implies that omega L minus 1 upon omega c, if I take square root on both sides, omega L minus 1 upon omega c is equal to plus minus r. Square root of r square will be plus minus r. So we can write omega 1L minus 1 upon omega 1c is equal to minus r, equation number 1, and omega 2L minus 1 upon omega 2c is equal to plus r. This is equation number 2. Why we have taken this? Because I know that the value, the smaller value plus minus r, out of these two values, plus r and minus r is the small value. And if we take omega 1, if we take the lower value of frequency, that is omega 1, then it will give me a lower value of r. That's why I have taken omega 1l minus 1 upon omega 1c is equal to smaller value, that is minus r, and the bigger value of frequency, that is omega 2l minus 1 upon omega 2c is equal to plus r, the bigger value of r. And this I have named equation number 1 and this equation number 2. Is this clear to you till now?
Yes.
Now we are going to add both these equations. Add equation 1 and 2. Add equation 1 and 2. Omega 1l plus omega 2l. So omega 1 plus omega 2 into l minus 1 upon omega 1c minus 1 upon omega 2c. So minus 1 upon c, and in the bracket we have 1 upon omega 1 plus 1 upon omega 2 is equal to minus r plus r. It will become 0. So omega 1 plus omega 2l, omega 1 plus omega 2 into l minus 1 upon c. And if we take LCM, so in the case of LCM, when we have two different terms in the denominator, then both the terms gets multiplied. Omega 1 into omega 2. Omega 2 into 1 is omega 2 plus omega 1 upon omega 1 omega 2 is equal to 0. Now let's move this term, this negative term, to the right hand side. We will get omega 1 plus omega 2 into L is equal to 1 upon c. Omega 2 plus omega 1 upon omega 1 omega 2. So omega 2 plus omega 1, here it is in the numerator and here also it is in the numerator. So they both will cancel out each other. And on to page number 25 we have now, we can bring this omega 1 omega 2 here and we can bring this L here in the denominator. So omega 1 omega 2 will be equal to 1 upon LC. 1 upon LC, equation number 3. This is equation number 3. So we obtained this equation number 3, omega 1 omega 2 is equal to 1 upon LC, by simply adding equation 1 and equation 2. Now we are going to do another thing. We are going to subtract equation 2 from equation 1. Subtracting equation 1 from equation 2. Yes, we are going to subtract equation 1 from equation 2. Subtracting equation 1 from equation 2. So now we are going to subtract equation number 1 from equation 2. So equation 2, let's write it on the top. Omega 2L minus 1 upon omega 2C is equal to R. Omega 1L minus 1 upon omega 1c is equal to minus r. We are subtracting it, minus, and when we subtract, the sign of the lower equation gets changed. So this is omega 1l, it will become minus omega 1l. This is minus 1 upon omega 1c, it will become plus. This is minus r, it will become plus. Omega 2 minus omega 1 into L. So we can take plus 1 upon c common, and what we will obtain in the bracket, minus 1 upon omega 2 minus 1 upon omega 2 plus 1 upon omega 1. R plus R is equal to 2R is equal to 2R. Now this is omega 2 minus omega 1 into L plus 1 upon c, and we are taking the LCM. So omega 2 into omega 1, omega 2, omega 1 Omega 1 into minus 1 is minus omega 1. Omega 2 into plus 1 is plus omega 2 is equal to 2r. So omega 2 minus omega 1 into L into L plus 1 upon C. What is this? Minus omega 1 plus omega 2. We can write it like this: omega 2 minus omega 1 upon upon omega 1 omega 2 is equal to 2r. Now omega 2 minus omega 1 is here in the numerator, and here also it is in the numerator. So we can take it out common. Omega 2 minus omega 1. Omega 2 minus omega 1 is here, and now L is here. L plus 1 upon C into omega 1 omega 2 is equal to 2r, is equal to 2r. Now from equation number 3 we know the value of omega 1 omega 2. From equation 3 we know that omega 1 omega 2 is equal to 1 upon LC, is equal to 1 upon LC. So it will become omega 2 minus omega 1, and in the bracket we have L plus 1 upon C. And what is omega 1 omega 2? It is 1 upon LC. So C will get cancelled out by this C, and this is 1 upon 1 upon L. So denominator gets multiplied to the numerator is equal to 2r. So what we will get? Omega 2 minus omega 1, in the bracket we get L plus L is equal to 2r. Is this clear to you till now?
Yes, sir.
So have you noted down?
Just give me 1 second.
Okay, okay. Okay, Anusha, you wait for 2 minutes. I am coming. You just note it down. I am coming in 2 minutes.
I'm not writing, sir.
Yeah, wait. Completed?
Yes, sir.
Okay. Now I'm moving on to the next slide. So here, what is this? Omega 2 minus omega 1 into L plus L. L plus L means 2L. So what was that? It was omega 2 minus omega 1 and L plus L. L plus L means 2L. Omega 2 minus omega 1 multiplied by 2L is equal to 2R. Is equal to 2R. Now we will cancel out this 2 with this 2, and omega 2 minus omega 1 is equal to R upon L. Omega 2 minus omega 1 is equal to R upon L. We will name it equation number 4. This is equation number 4. Now, what is Q factor? Therefore, this Q factor Q is equal to omega R, resonant frequency, upon twice of delta omega is equal to omega R upon, what is this twice of delta omega? It is omega 2 minus omega 1. So Q is equal to omega R. We will write it in the same manner, omega R. And what is this omega 2 minus omega 1? It is R upon L. So we know that denominator of denominator comes and gets multiplied in the numerator. So Q is equal to omega R into L upon capital R. This is equation number 5. Omega R into L upon capital R. This is equation number 5. The above equation can also be written as, this equation can also be written as Q is equal to omega R into L upon R, and if you multiply it by this one IRMS and multiply denominator also by IRMS, then what we will get? What is this omega RL? Actually, omega R is nothing but omega. This is the value of omega at resonance condition. So omega into L is nothing but it is equal to XL, and XL is inductive reactance. And if you multiply this XL with IRMS, then this is called voltage drop. If we multiply this reactance is simply resistance offered by an inductance is called inductive reactance. So voltage, so this is resistance multiplied by current. We know that it is voltage. Voltage across L or C. Voltage across L or C. And what is this I into R? I into R is applied voltage. This is the applied voltage. And this ratio, we also call this ratio as, okay, why we have written is voltage across L. Across L is understood. We can understand that omega into L is XL. XL is inductive reactance. So inductive reactance multiplied by current is voltage across inductance. But why I have written this or omega C? Because in resonance, this one, omega L is equal to 1 upon omega C. In resonance condition, this one, omega L is equal to 1 upon omega C. And what is this 1 upon omega C? It is capacitive reactance. It is XC. And if I multiply XC by I, then we will get voltage drop across capacitor C. That's why I have written voltage across L or C upon applied voltage. This ratio is also called as voltage magnification. We can also call it as voltage magnification. Voltage magnification. Now, omega R is equal to 1 upon under root LC, 1 upon under root LC, or omega R square is equal to 1 upon LC. Now, we can write it like this, omega R into omega R is equal to 1 upon LC. Let's bring L here. Omega R into L is equal to 1 upon omega R into C. Therefore, equation 5 can also this equation 5 can also be written as Q is equal to this equation 5 can also be written as Q is equal to 1 upon R into omega RL and what is this omega RL? It can be written as 1 upon omega RC into 1 upon omega RC. We will mention reason here from equation 6. From equation 6. Now Q is equal to or Q is equal to 1 upon R into L into omega R, 1 upon R into L into omega R, or Q is equal to 1 upon R into L. And what is this omega R? Omega R is 1 upon under root LC. And Q is equal to 1 upon R into L into 1 upon root L into 1 upon root C. Okay, now what is this L? We can write it like this also, 1 upon R and root L into 1 upon root L into 1 upon root C. Root L will get cancelled out by this root L. Root L upon root C. Q is equal to 1 upon R into root L upon root C. 1 upon R multiplied by under root L upon C. So this is also an expression for quality factor. So here till here everything has been completed of this series resonance LCR series LCR circuit, and all the resonance condition is also completed here. All the type of expressions. This one sometimes they ask that please prove that quality factor is equal to voltage magnification. Sometimes they ask that prove that Q is equal to 1 upon R into under root L upon C. So the derivational part is over now. Now we have to do some numericals based on these concepts. Is this clear to you till now?
There are a lot of derivations, right, for like
Yeah.
for like physics.
Yeah, physics have, in physics we have so many derivations, and what I have observed, I was also going through that exam idea book. What I have observed that in the foreign board of CBSE, which you are studying in, so in that board, the weightage of this derivation is more than the numerical part. I have observed this.
Yeah, theory and derivations is like important too.
Yeah, this one is more important. Okay, let's do some questions also. Have you completed till here?
Yeah, so.
Okay. Now, onto the same page of your PDF, question number 1. Question number 1. This question number 1 is determine the impedance of a series LCR circuit. Determine the impedance of a series LCR circuit if the reactance of C and L are 250 ohm and 220 ohm respectively, and R is 40 ohm. So what are they saying? Determine the impedance of a series LCR circuit. So impedance of a series LCR circuit is given by given reactance of C and L. Reactance of C and L. What is this? Reactance of C is capacitive reactance. XC is 250 ohm and XL is 220 ohm. XL is 220 ohm and R is 40 ohm. Therefore, impedance of series LCR circuit is Z is equal to under root R square plus XL minus XC's whole square. Under root R square plus XL minus XC whole square. We can write it XC minus XL whole square also, because 3 minus 2's whole square is also 1. 3 minus 2's whole square is also 1, and 1 minus 3's whole square is also 1. So we can write it in any way. We can write it XL minus XC's whole square or XC minus XL, it's up to you. So Z is equal to under root, what is R? R is 40. So 40 square plus XL minus XC. 220 minus 250. 220 minus 250 is whole square. Now Z is equal to the square of 40 is 1600 plus 220 minus 250 is minus 30 and minus 30's whole square is 900. So 1600 plus 900 is 2500 and the square root of 2500 is 50 ohm. 50 ohm. Okay. Now, question number 2. Question number 2. Question number 2 is resistor. A resistor of 50 ohm A resistor of 50 ohm. Is this clear to you? Is this question clear to you?
Yes.
Okay. Now let's switch on to question number 2. It's a resistor of 50 ohm, comma, an inductor of 20 upon pi Henry, and a capacitor of 5 upon pi microfarad. Mu means microfarad. They are connected in series to a voltage source of 230 volt 50 hertz. Always remember that they are saying that they are connected to a voltage source of 230 volt. So whenever this voltage is given in an AC numerical, in an alternating current numerical, whenever this voltage is given, this voltage is ERMS. This voltage is RMS value. Okay. So a resistor of 50 ohm, a resistor of 50 ohm, an inductor of 20 upon pi Henry, 20 upon pi Henry, and capacitor of 5 upon pi microfarad. Capacitor of 5 upon pi microfarad. What is this micro? Micro means 10 to the power minus 6. 5 upon pi into 10 to the power minus 6 farad. All right. And they are connected in series to a voltage source of this one, 230 volt. So ERMS is equal to 230 volt, and frequency F is equal to 50 hertz. Find the impedance of the circuit. So they are asking us again to calculate the impedance of the circuit. Impedance means they are asking for this Z. So the value of ERMS, it is actually not required. I will see that. XL. What is XL? XL is omega L. And what is omega? Omega is 2 pi F into L. So 2 pi, and the value of frequency is 50. This time it is 50. And what is L? L is 20 upon pi. Pi will get cancelled out by this pi, and 52 is 100. 100 into 20 is 2000. So 2000 ohms. XL is equal to 2000 ohms. Okay. Now next, XC. XC is 1 upon omega C. So 1 upon omega is 2 pi F into C is equal to 1 upon 2 pi. What is F? F is 50. And what is the C? C is 5 upon pi into 10 to the power minus 6. 5 upon pi into 10 to the power minus 6. Okay. Pi will get cancelled out by this pi. And 52 is 100. XC is equal to 1 upon 52 is 100. 52 is 100 into 5 into 10 to the power minus 6 into 5, and 10 to the power minus 6 will go to the numerator and it will become 10 to the power 6. And 100 means 10 to the power 2, it will become 10 to the power 4. So XC is equal to 1, 2, 3, 4 upon 5. So 5 2s are 10 and 2000. XC is equal to 2000 ohms. Therefore, impedance will be, what is the value of impedance? It is Z. Z is equal to under root R square plus XL minus XC whole square. Under root, what is R? R is 50. So 50 square plus XL is 2000, XE is also 2000. 2000 minus 2000's whole square, it will become 0. What we will get? We will get 50 squares under root, and what will be the value of this? It will be 50 ohm. 50 ohm. Is that clear to you?
Yes.
Let's switch on to the next question. Question number 3. A 0.3 Henry inductor, 60 microfarad capacitor, and a 50 ohm resistor are connected in series with a 120 volt 60 hertz supply. Calculate first part impedance of the circuit, second part current flowing in the circuit. Impedance and current we have to calculate. So have you noted down till here?
Yes, sir.
In question number 3, we have a 0.3. The value of inductor is 0.3 Henry, 60 microfarad capacitor. So C is equal to 60 microfarad means 10 to the power minus 6 farad. And a 50 ohm resistor, R is equal to 50 ohm, are connected in series with a 120 volt 60 hertz supply. So this time the frequency is not 50 hertz, this time it is 60 hertz. 120 volt means ERMS is equal to 120 volt and F is 60 hertz. F is 60 hertz. So calculate impedance of the circuit. Calculate impedance of the circuit. What is XL? XL is equal to omega L. XL is equal to omega L. What is omega? It is 2 pi F into L. 2 pi F into L. So 2 pi, what is F? F is 60. And what is L? L is 0.3. So this time 0.3, the decimal will go and 10 will come here. So 6 3s are 18. 2 pi into 18 and 18 2s are 36. XL is 36 pi ohms. But in the answer we should not have this pi term. So pi, what to do with this pi? Okay, please write the value 3.14, 36 into 3.14. So just to save time, I am doing it with the calculator. 36 into 3.14. 36 multiplied by 3.14. So this is 113.04. 113.04 ohms. This one is XL. Now I am going to calculate XC. XC is equal to 1 upon omega C. Again 1 upon 2 pi F into C So XE is equal to 1 upon 2 into 3.14 into F is 60, and the value of C is 60 into 10 to the power minus 6. 3.14 decimal will go from here, 2 zeros, we'll cancel out these 2 zeros. So XE is equal to 10 to the power minus 6 will come into the numerator, 10 to the power 6. 2 into 314 is 628 multiplied by 6 is 36. So XC is equal to 10 to the power 6 upon 628 multiplied by 36. 628 multiplied by 36 is 22608. 22608. If I divide 10 to the power 6 by 22608, we will get 44.23. 44.23 ohms. Now, therefore, Z is equal to under root R square plus XL minus XE's whole square. Now, what is R? R is 50. So, 50 square plus XL minus XE. XL is 113.04 minus XE is 44.23 square. So 50 square is 2500. 113.04 minus 44.23. 113.04 minus 44.23, it is 68.81. 68.81. Sorry, 68.81 whole square. 68.81 into 68.81. It is 4734.8161. 4734.8161 plus 2500 7234 0.8161, and if we take the square root of this, it is 85.05. 85.05, which is approximately equal to 85 ohm. Is that clear to you? Impedance?
Yes.
Okay. After that, the second part of this question, they ask here, current flowing in the circuit. Current flowing in the circuit, it is simple. IRMS. They are asking about IRMS. Current flowing in the circuit. IRMS is equal to ERMS upon Z. What is this ERMS? ERMS is 120 and Z is 85.05 or 85. You know, simply write 85 also. So 120 divided by 85.05, this is 1.41. 1.41 ampere. Is this clear to you till now?
Yes, sir.
So Anusha, I am leaving the next question for you. Only last question is left. And after that, we have some small topics. Power in an AC circuit, power factor, and some questions based on power. And the major topic which is left is transformer. Transformer is a theoretical part. We will do it tomorrow. If you have time, we can take class tomorrow also.
When?
You tell me. You tell me. As per your comfort, I will arrange my other classes.
Anytime like morning, evening, I'm free. Like from afternoon to evening.
You tell me the Dubai time. You tell me.
Dubai.
You tell me Dubai time.
It will be 4:30 India time. 4:30 India time onwards to the night and free.
4:30 India time. Okay, okay, okay. Okay, Anusha, I will inform you. I will inform you through message only. Okay.
Okay.
Okay, bye bye.
Thank you, sir.
Okay, bye.
Have a good night.
Good night.